So I have a drawing here, just a simple drawing showing the top of a plug with the chambers, 5 chambers drilled into the plug. And the point here is that no matter how precise they are, they're not going to be perfectly aligned. And because they're not perfectly aligned, now these are exaggerated. They're not going to be this bad. This is just an exaggeration to make the point. But even if they're off just 1 or 2 thousandths, it's going to make a difference. And so what happens is if you put tension on the plug to rotate the plug, the pins inside the chambers will hit against the wall of the shell. And so, for example, in this example, if you turn this clockwise, in other words, it's going to move this over, this one being the furthest to the right, this pin stack would hit against the shell first. And if you lift up on that while holding tension, turning tension on the plug, it will trap that upper pin above the shear line. And so if it traps that one, the next one probably would be this one right here. It looks like it's the next furthest to the right, and then this one, and then this one, and then finally this one. Now if you were rotating it to the counterclockwise, going this direction, then this one here obviously would hit first, probably followed by this one, this one, this one, and this one. So it's the alignment, or we should say the misalignment of these chambers that is going to help us to pick the lock open. There's a drawing that I have showing a tension wrench in the top of the keyway, putting pressure on the plug with a hook pick, sliding in the keyway underneath the tension wrench and picking up the pins in the first chamber. Here's a drawing showing the tension wrench at the bottom of the keyway and using a rake pick to rake the picks with, which would be going in, sliding in over the top of the tension wrench. The idea is that we can go into the lock, put tension on the plug so that it tries to turn one way or the other, and then pick these pins up one at a time until the top pin is trapped above the shear line. Possibly we go to the middle pin, the 3rd pin, and we pick it up. We trap its top pin. We may feel the plug move slightly. Then we look for the next pin that might be kind of sticky. Which pin is sticking a little bit? That's the one that will trap next, usually. That's the one that will trap the easiest. So we just go from pin to pin, looking for which one has a little bit of stickiness to it, and we push that one up until all 5 of the top pins are trapped above the shear line. Okay, so I put this plug back into this mortise cylinder, and I want you to notice that the plug will turn a little bit. In the locked position, it will turn slightly. And that's what we're going to use to put the tension on the pins. As this comes around up here, the side of this plug will press against the pins, and that will allow us to push the bottom pin up, trap the top pin above the shear line, and hold it there. So that's the theory. As you begin your study of lock picking, recommend first that you take a half diamond or a hook pick and go in and just explore what the pins feel like in the lock. Pick them up, count them, get used to how much tension is on the pin stacks. And once you've done that, then put a little bit of pressure on that plug with your tension wrench, very, very light, and see if you can feel one that's now a little sticky. That's the one that we want to pick up first. We're going to pick it up and then go to the next one. Now you notice I'm letting the pressure off the tension wrench. If I don't feel what I'm looking for, it's possible I pushed one of the pins too high right off the bat, and it's not gonna unlock. So I let the pressure off and start over. You can hear them drop back down. There it is, just like that. Lock is opened. So that's the theory behind picking locks. We use the following 4 elements to pick locks: knowledge of the locks, manufacturing flaws, design flaws, and lock picking tools. Please take just a moment to like the video and also subscribe to our channel. Thanks for watching.